Hello everyone. Welcome to my channel. Myself Dr. Munsifa Firdos Khan Barbuya. In this video, I have explained the basics of data structure. I have tried to explain the data structure in a very easy language. I hope you will understand whatever I have explained. Watch the video till the end everyone. Thank you. These are the contents of the videos. First, we are going to understand what is a data structure, then arrays, then linked list, then stack, then queue, then tree, and graph. Now, what is a data structure? Before understanding what is a data structure, let us first understand what is a data. Data means values or set of values, and data structure means logical or mathematical model of particular organization of data is called a data structure. And the data structure is further classified into two types. First is primitive data structure and second is non-primitive data structure. Now primitive data structure, it consists of basic data types like integer, real, character and boolean. And non-primitive data structure is further divided into two parts. One is linear data structure, another is non-linear data structure. Now linear data structure, in linear data structure the elements of data are arranged in a sequential fashion, that is in linear order, and in nonlinear data structure the elements are not arranged in a sequential fashion. Now linear data structure are further classified into the following types. First is array, second is linked list, third is stacks, and fourth is queue. And nonlinear data structure are further classified into trees and graphs. In this video we will understand all these linear and nonlinear data structure one by one. Let us understand what are arrays. Arrays are the collection of similar types of data items stored at a contiguous memory location. Now, arrays are the derived data types in C programming language. That means it consists of a basic primitive data types such as int, character, float, etc. Now, these are the simplest type of data structure. That means an element in an array can be accessed with the help of its index number. Now, arrays are further divided into two types. First is 1D array, that is the linear array. For example, one example of linear array is suppose int marks 5. So that means I am storing marks of 5 different subjects of a particular student. So this can be stored as marks 0, marks 0, marks 1, then marks 2, marks 3. Suppose this is 4 elements. So this is an example of a linear array. So these are this is one of the way we represent an array. Let us understand what is a 2D array. 2D array is represented in terms of matrices. That is, the elements are represented in terms of rows and columns. So rows and columns, let me show you. So int a 3 3. 3 is the number of rows, 3 is the number of columns. That is, in terms of rows and columns we can represent arrays. This is 1 2, these are columns and these are rows. 0 1 2. So a 0 0, a 0 1, a 0 2 and so on. So this is a 3 by 3 matrix. This is an example of a two-dimensional array. Let us understand what are linked lists. Linked lists are linear data structure which consist of a series of connected nodes. That means a node is divided into two parts. First part consists of the data part and the second part consists of the pointer. That means the address of the, it points to the address of the next node. Now it is further divided into various types. First is the singly linked list. So singly linked list, a node is divided into two parts only. Where, so let me give an example of a singly linked list. So this is an example of a singly linked list where the last node will contain a null pointer. Now next is the doubly linked list. In doubly linked list, a node is divided into three parts. The first part, this part, it will contain a pointer which points to the previous node. This will contain the data part and this will contain the next pointer. That means it will contain the address of the next node. This is a doubly linked list. Next is the circular linked list. In circular linked list, the last node, it does not contain a null pointer. Instead of that, it will point to the first node of the list instead of a null pointer. Next is the circular doubly linked list. In circular doubly linked list, the next pointer, let me draw first as doubly linked list first. This is the previous pointer, this is a data, and this is the next pointer. Now in circular linked list, the last node will point to the first node, and the first node, it will point to the last node. So this is an example of a circular linked list. Now let us understand the difference between arrays and linked lists. Some of the points I have listed out here. First is, array is a collection of elements of similar data types, whereas linked list is a collection of nodes where each node is divided into two parts. First part consists of the data part, whereas the next part consists of the pointer part. That means it contains the address of the next node. Next is, elements in array are stored in contiguous memory location. Contiguous memory location means elements are stored in sequential order, one after the other. Whereas elements in linked list are stored anywhere in the memory. That means they are stored randomly, no specific order. Next is, arrays works with static memory. That means here memory size is fixed. Memory size is fixed. That means once it is initialized, we cannot change the size of a memory in array, whereas linked list works with dynamic memory. That means the size of the memory can be changed on our own convenience at runtime. Next is, elements of an array are independent of each other, whereas elements of linked list are dependent on each other. That means we know that here one node points to the next node. Definitely, so each nodes are dependent on each other. Now memory in array are allocated at compile time, whereas memory in linked list are allocated at runtime. Now in array, it takes more time while performing operation like insertion and deletion, and whereas in linked list, insertion and deletion are easier. Because in array, elements are arranged in this manner. So if you want to insert an element, then we have to shift the entire list of elements. So it leads to slow down the process. Whereas in linked list, suppose we want to insert an element, so we can insert it here and we can add the pointer, and then we can point to the next node. So that's why insertion is the same way. Deletion also, it's very easier in linked list, whereas deletion is also difficult in array. Next is, accessing any element is faster in array, because in array we can access any element with the help of this index number, whereas accessing any element in linked list is slower, because in order to access any element in a linked list, we have to traverse from the very first element, and that's why it is slower. Now let us understand what is a stack. Stack is a linear data structure that follows LIFO. LIFO means last in first out principle. That means whenever an element is inserted at the last, will be deleted first. That means it contains only one pointer, that is the top pointer. That is, only at one end all the elements, this is the top pointer where all the insertion and deletion will be performed at this one end, and the elements which is inserted last will be deleted first. These are the two operations. First is the push. Push means whenever we want to insert an element at the stack, suppose push, already in the elements we have this push 3, so 3 is inserted here. So at the top of the element we have done, that is push. Push means insertion operation, and pop means deletion operation. Now let me write pop 3. So we want to delete the element, so pop 3 will be this. So the insertion and deletion are done at the top of the element, that is the top pointer, where push and pop, both the operations are performed in a stack. Now let us understand what are queues. Queues are a linear data structure that follows FIFO policy, that is first in first out. The element that is inserted first will be deleted first. That means it enables insertion operation to be performed at one end called the rear, whereas deletion is performed at another end called the front. Suppose this is a queue. So this is rear and this is front. So deletion will be done here, whereas insertion will be done here. Now let me give a practical example of a queue. Suppose students waiting for admission in a college or university. So this is a queue. Definitely the students who has come first will get the opportunity to take the admission first. Who has come second will get the second opportunity, and so on. So that's the example of a queue. Now it is divided into further types. First is simple queue or linear queue. So this is an example of a simple queue or linear queue. Next is the circular queue. In circular queue, what happened? The last element will point to the first element. It will form a circle. So this is a circular linked list example we can say. So basically this circular linked list is used whenever suppose it is a situation when the front elements are empty. Let me give you an example here. Suppose this is the case. Here front is empty and this is 3 and 4. Here rear is 4 and 1, 0, 1, 2. And front is 0. Now we can see 4, 5. We know that insertion happens at rear only, and here rear is 4 which is full. So in that case we can see that front are empty. So in order to utilize this empty space, we can use circular queue, which will point to the last element will point to the first element. Next is the priority queue. Priority queue means that every element has some priorities assigned with some priority. The element with the highest priority will be deleted first. And next is the double-ended queue. Double-ended queue means the insertion and deletion will be taken place at both ends. Insertion as well as deletion. Insertion as well as deletion. So this is an example of a double-ended queue. Now, let us understand the difference between stack and queue. Some of the points have been listed out here. First is that stack follows LIFO policy. We know that the elements which is inserted last will be deleted first. So this is a stack and this is the top pointer where the element which is inserted last will be deleted first. Whereas in queue, we know that it follows FIFO policy. That means the elements which is inserted first will be deleted first. That is, deletion will be taken place at front and insertion will be taken place at rear. So we know that a stack has one end, as already mentioned, that is the one end. In one end both the insertion and deletion will be done, whereas queue has two ends, that is the front and rear. Two ends are there where at front deletion is done, at rear insertion is done. We know that stack performs two operations, push and pop. Push means insertion and pop means deletion. Whereas queue performs two operation. We know that NQ and DQ. NQ means insertion, DQ means deletion. Now stack is simpler implementation, whereas if we compare queue with stack, then it is a little complex implementation. Now if we visualize stack, then we can see it's a vertical collection. That means, see, this looks like a vertical collection, or let me give an example, a stack of disk. So this is a vertical collection, we can say, as a example of a stack. Whereas queue, if we visualize it, it can be an horizontal collection. So if we consider students standing in a queue, so definitely if we visualize, it's a horizontal, whereas a stack of disks, it's a vertical. So that's some of the differences of stack and queue. Next is tree. Now we know that tree is a nonlinear data structure, and here elements are represented in a hierarchical form, and the topmost element of a tree is called the root node. Now see, let me draw an example of a tree. So this is an example of a tree where all the elements, these are nodes, where all the nodes are represented in a hierarchical form. So 1, 2, 3, 4, 5, 6, 7. Let me give them a number so it will be better for us to understand. Now this 1 is the first element of a tree and this is called the root node. Root node is the first element of a tree. Next is 2 and 3. 2 and 3 we can say that these are the internal nodes. These are the internal nodes. An internal node must have at least one child. So these nodes have two childs each. So these are the internal nodes. And 4, 5, 6, 7, these are called leaf nodes. Leaf nodes means a node which does not have any further child. So these are leaf nodes. Now one more thing, we can say that 4, 5 are siblings. 6, 7 are siblings. 2, 3 are siblings because 2, 3 is associated with root 1 and root 1 is the parent of 2, 3 and 2, 3 are siblings. In the same way, 4, 5 are the child of 2, root number 2. So we can say that 2 is a parent node of 4, 5 and 4, 5 are siblings. In the same way, 3 as well as 6, 7. So this is a example of a tree. Let us understand the various types of trees. First is the binary tree. So if we say this is an example of a binary tree, where in a binary tree, a node can have at max two childs. That means this is a node, this is also a binary tree, this is also a binary tree, this is also a binary tree. So a node which does not have any child is also a binary tree. At max two child it should have. So it can be 0, 1 or 2. Next is the binary search tree. Now in a binary search tree, a node can, this is the root node. The root node should be greater than the left child and it should be less than the right child. That means if I consider 30, then 20 should be its left child and 40 should be its right child. So this is a binary search tree where root should be greater than its left subtree and root should be less than its right subtree. Next is an AVL tree. AVL tree is a balance height tree where each node should be balanced and the balance factor is calculated in terms of left subtree minus right subtree. And a node having values from -1, 0 and 1 is considered to be balanced. If a tree having a node which is exceeding this number, then we can say a tree is not balanced. It can be -2 or it can be +2 also. If the values lies this in this way, then we can say the tree is not balanced, then we have to rebalance it. Otherwise, if if the elements having -1, +1 and 0, then we can say the tree is balanced. So that's the AVL tree, balance height tree. Next is the B tree. B tree and B plus tree both are MA trees. In B tree, the keys as well as the records are stored in both the internal nodes as well as the leaf nodes. This is an example of a B tree where the keys as well as the records are stored at both the nodes and the leaf nodes are not connected. They are not connected with each other. Whereas in B plus tree, the leaf nodes are connected with each other and the records are stored at only the leaf nodes and the internal nodes will have only the keys. So let me draw it here. So this is an example of a B plus tree, we can say. So where the leaf nodes are connected with each other, that is the B plus tree, and B tree, the leaf nodes are not connected with each other and at both the internal nodes as well as the leaf nodes have both the keys and records, whereas in B plus tree the only the leaf nodes have the records and the internal nodes have the keys. So one more thing is that in B tree, deletion of this internal node is difficult, whereas deletion is very easier as the data is kept at the leaf nodes in B plus tree. Next is graph. Graph is also a nonlinear data structure, which is a group of vertices and edges that are used to connect these vertices. So A is a vertices, B is also a vertices, and this is an edge. So these two vertices are connected with this edge. So we can say this is a graph. So let me consider ABC. So this is an example of a graph where these vertices are connected with these edges. So let us define a graph. A graph G can be defined as an ordered set GV of E. That means V is vertices and E is edges, where V of G represents the set of vertices and E of G represents the set of edges which are used to connect these vertices. Now, graph are divided into two types. First is the directed graph and next is the undirected graph. Now, directed graph means what? Edge is associated with a, whenever an edge is associated with a direction, then we call it a directed graph. Now, A, B, C, this is a directed graph. Now, the undirected graph means when the edge is not associated with any direction, so that's an undirected graph. So ABC, that's a directed graph, and this is an undirected graph. Now let us understand the difference between tree and graph. Some of the points have been listed out here. First is tree is a collection of edges and nodes. We know that tree is a collection of edges and nodes, so we can represent T as edges and nodes. Whereas graph is a collection of vertices and edges, so we can represent graph as vertices and edges. Next is it has a unique node known as the parent node. We know that tree has a unique node and that is called the parent node. These are the parent node. Whereas graph does not has any as such node. Now tree does not create any loop or cycle. In tree it does not forms any loop or cycle, whereas graph it can have. So this is also a graph we can say, and it is a cycle. Now, tree represents data in a hierarchical model. We know that this is in the multiple level, tree represents data. So that's a hierarchical model, whereas graph represents data in network model. In tree, all the edges are always directed. The tree, all the edges are always directed, whereas in graph, we have seen that undirected edges are also there, directed edges are also there. So next is that tree is used for inserting, deleting or searching any elements, but graph is used for finding the shortest path in the network. So these are some of the difference of tree and graph. Thank you everyone for watching the video till the end. Like, share and subscribe the channel for more videos. Thank you.